Aloha, everybody. Hope everybody's doing well. We have our next homework assignment out of the book. It's CPM 7.3.4. Okay. If you like the page number, it's going to be on starts on page 368. So I'm going to write 368 and 369. Okay. And the numbers that we're doing here are 7-121 all the way through 7-130. Okay, so it looks pretty long. Look at that. I got zoomed in a little bit, maybe a little bit too much for you right now, but there's a lot of problems there. But a lot of cool review, a lot of cool problems to do, and it won't be too hard, especially if you follow along with us and watch the video. All right. All right. So that first problem is, first off, get the easiest 3 points, right? Easiest 3 points only takes about 40 seconds. We're going with Malcolm Gladwell as our student name today. He's one of my favorite authors of nonfiction books. Okay, that means he's not making up a story. He's actually reporting truth, right? And he just wrote a book called that reports the truth. One of my favorite books of his is called Outliers, and it just sort of analyzes a bunch of different things and coincidentally, maybe that's one of the reasons I like him a lot. A lot of his books have information that I think I can use that information in a wise way to help me become a more effective teacher. So a lot of information is applicable. It means you can apply it to education. So pretty cool author. David and Goliath, What the Dog Saw, The Tipping Point, Outliers is I think his most famous one. So here we go. First problem is write an equation. We get to write an equation, okay, and solve it. Be sure to define your variable. What does that mean? Well, we'll go over it, okay? The regular price of your favorite jeans has been reduced by $18. That means it went down by $18, right? It wasn't so much. It's $18. That doesn't mean it costs $18, okay? That's how much you're saving. They are now on sale for $26. What was the regular price? Well, let's figure it out. Okay. Well, we got these jeans, right? And the regular price, we don't know, but the price of the jeans went down. Okay. The price of the jeans went down. So I'm going to say we subtract the price of the jeans, we minus. How much did it go down? It went down. Oops, let's zoom out a little bit so you can see that. See them both at once, okay? All right, so the price went down by $18. And now they only cost $26. Okay, so we kind of just based on what they told us made a problem. Now, if we want to make what's called an algebra equation, right? Then we kind of have an equation here, but you don't want to have price of jeans in there. So we're going to create a variable for that. Now you can use X, right? You can use N for the number you don't know. But oftentimes, if I'm making an equation, I'm creating it. I'm allowed to use anything I want. Okay. So I will usually use a letter that will sort of stand for something that helps makes sense, and it helps me know what it is when I solve the equation, right? So I'm thinking I'm going to either use a P or a J here, either P for price or J for jeans. Okay. Okay. Some people might use an O for original price, right? But I don't like to use O's or I's too much because it looks too much like a 0 or a 1. Okay. So let's use a P. Okay. And we're going to say the price of the jeans minus 18 equals $26. And then now we want to go solve that. Okay. Now I'm going to get you started on that just by reminding you our goal is to get the P by itself. I'll give myself some space to get rid of something. I want to get rid of everything except for that P on that side. So I'm getting rid of a minus 18. And you do that by using the opposite operation, the opposite of minus 18. And don't forget, if you do it to one side of the equation, do Do the same thing to the other side. Do it to the other side of the equation and then solve it. Okay? All right. How about 7, 1, 2, 2? Okay. What are we doing on that one? Rewrite each expression using the distributive property. So remember, this is 5. That parentheses, that means 5 times everything inside. Now make sure you multiply it by each of those things inside. Each term is what we say. So I got to go 5 times 2x plus 5 times 1. Don't give me 10x plus 1 for your answer. You got to do it to each thing inside. That's what distributive property is all about. This 34 on the next one, I'm multiplying it by the x, 34 times x, minus, not minus 1, minus 34 times 1. Make sure you multiply it by each thing inside. That's the whole idea of the distributive property. Same thing here. 9 times x plus 3. It's going to be 9 times x plus 9 times 3. I'm going to leave that one for you guys. I think you guys got it. Elevator challenge. I love these kind of problems. You just can't do it easily, right? So Juan got on the elevator at the middle floor of a building. He went up 4 floors, down 3 floors, okay, up 1 floor, and then down 9 floors, where he left the elevator on the ground floor. How many floors are in the building? Explain how you found the number of floors. So this is one of those things, you start, okay, we don't know where he was, okay. Let's say he started on the X floor, okay. And now let's make our problem. He went up 4 floors. So is that going to get bigger or smaller? Okay, that's going to get bigger. So I'm going to say, write that up above the plus. Okay, and then he went down 3. Is that bigger or smaller? That's smaller, right? Down 3. So I'm going to do minus 3. Right? Then up 1. Is that bigger or smaller? Right. Up is plus. That's 1. And then down 9. Is that bigger or smaller? Down is going to get smaller, right? And then that, he got off on the ground floor. Okay? So is the ground floor the first floor or the 0 floor? I think most people call it the first floor, right? So we're going to say that equals the ground floor is 1. Do all the math. See if you can solve it. Okay? Those are some good questions there. I'm going to let you play with that because that's one of those puzzles, and it's more fun if you solve the puzzle than watching someone else solve the puzzle. Right? 124. Each of the following pairs of diagrams shows a first and second step that could be used to represent a multiplication problem. For each pair, write a multiplication problem for a solution. So, okay, this is a visual representation. Okay, so I got a rectangle. Looks like it's divided into thirds. Looks like 2 of them are shaded in, right? And then the next rectangle, it now looks like instead of just thirds, now it's sixes, right? And everything is sort of shaded in like the first one, but these top 2 boxes are shaded in darker. Okay, so I'm saying this looks like 2/3, right? And what did I do to that? I did something to it. And do they? Yeah, they actually tell you it's going to be a multiplication problem to equal that. All right. So 2/3 times what equals this? Okay, because it looks like now the dark ones are 2 6, right? So let's see if you can figure that one out. I think that's kind of a fun one to try too. Same idea here. Now we have 6 circles, and 5 of them are shaded in. Okay, and it moves to okay, where each of those circles looks like it's been cut into 4, right? And those 5 original shades are there, but now one of those fourths is shaded in darker than the rest. So now, okay, it looks like 1, 2, 3, 4, 5 of the 4, 8, 12, 16, 20, 24 is shaded in. Okay. I'm going to let you try that one. Okay. Again, I want to get you started, but I want you to finish. So we have her 125. This is Jancy. Okay. She bought a new package of border decoration. Okay. She bought a new package of border decoration to put around the bulletin in her bulletin board in her classroom. Oh, must be a teacher. The package contains 300 inches of border. The dimensions of the rectangular bulletin board are 8 feet by 3 feet. If she puts the board around all 4 sides, how much leftover material will she have? Okay, so it says include a sketch when you get your answer. Well, I think that's, if you could draw a picture to help you solve or understand a problem, do that. Okay, so she got a bulletin board. It's a rectangle. It says it's 8 feet by 3 feet. Okay, and she has 300 feet? No, she has 300 inches. Okay, so she has to go all the way around with that border. Okay, how much is going to be left over? So we're assuming that that's enough. But I got inches and feet. What's the perimeter of this? Okay, well, do I want to switch these to inches, or do I want to switch that to feet? Okay, how about if we figure out the perimeter with feet first? Okay, because feet is going to be a smaller number than inches, right? Each foot is how many inches? Hopefully you know that's 12. Okay, so let's do 3 plus 8 plus 3 plus 8, and that'll tell me how many feet. Okay, so the perimeter equals 3 plus 8 plus 3 plus 8. That'll tell you how many feet. Okay, what we need to do is to figure out how many inches that is. Okay, and if each foot is how many inches? Okay, so I'm going to put that there and multiply it by 12 to find out how many inches. Okay, and then I'm going to come up here and subtract it from the 300. Why am I saying I'm going to do that? You're going to do that. All right, go get busy. Okay, you can watch my video when I finish it tomorrow and see if we get the same answer. All right, next page, right? 126. Write an inequality. Okay, now we haven't really gone through that. I mean, if you would have done all the problems in class in this section beforehand, you know about inequalities. Okay, and they do show you about graphing inequalities a little bit in this box, right? But inequalities is kind of like when you make a problem, but instead of saying something equals something, you're saying it is bigger than something or it is smaller than something, right? That's where the inequalities is not equal. But you can make problems like that, and sometimes it comes in handy. And here's the situation. All right, so Western Airlines will allow you to fly with suitcases that weigh no more than 50 pounds. No more than 50 pounds. If your suitcase weighs 8 pounds and the school books you need to bring weigh 11 pounds, how many pounds of clothes or other items can you pack? Okay, well, I can do my 8 pounds, right, of the suitcase. And remember, to abbreviate pounds, it's LPS. And my 11 pounds of books and figure out what that is. Okay, now I think most of you can do 8 plus 11. I'm going to wait. Hopefully figure it out. It was 19 pounds. Okay, and that's my suitcase and books. Okay, so I have my suitcase and books. I have my 50-pound limit, and I have 19 pounds so far. So if it was completely equal, how many pounds would make of clothes will add up to make 50? Well, it's 50 minus 19. Okay, but I don't want it to be equal. I want it to be either bigger or smaller. Do I want my number of pounds to be bigger or smaller than this number? Well, I can't have it be too heavy, so I want it to be smaller. So what we have here, and this is where we get to come up with an equation, since we're talking about clothes here, right? I'm going to say my clothes C has to be less than 50 minus 19. Okay? Now, I can really say it could be equal to that, right? So this is how you do a less than. Remember left hand less than, and then you can turn that into the word less if you want with it, make it an L, right? And that's greater than, right? And you have to sort of put a backward C to make that a G, right? But that means less than. This symbol means less than or equal to. Okay, so we might do that on this one. Okay, all right, I'm going to let you figure out what it is. 7-127, write an equation for the problem below. Okay, and define your variable. You want to buy a new computer. It costs this much. You check your savings account and realize that to buy it, you will need 125 more than you have right now. Okay, how much more do you need in your account? Okay, so I'm going to say what I have equals H. And what I have plus how much more? I need 125 more equals enough to buy that $2,250 computer. There is an equation. That's not the only one you can do, okay? But I'm going to let you try to solve it, okay? And if you had another equation, that'd be awesome. Share it. 7-128, it says to use the giant 1 to change the following fractions to a number with a denominator of 100. So this is a weird problem. I was looking at this earlier. Okay, and I want the denominator to be 100 down here. Okay, so what do I multiply 200 by to get 100? Well, wait a minute. You can't multiply a bigger number. Yeah, if you multiply it by a number smaller than 1. Okay, and we usually don't use the giant 1 for that, but we're going to. Okay, what do I multiply 200 by to get 100? Well, 1/2. Now, if there's a 1/2 on the bottom, a 1/2 has to go on top. So I'm multiplying this by 1/2, which is like dividing it by 2. Okay, you're going to do 85 times 1/2 and then figure out what that answer is and what goes there, right? And this next one is just maddening. Why did they give us? Okay, now we're talking about 17/15ths, and I want this to be 100. And the reason this is maddening is because I need to multiply 15 times what to get 100? Well, it doesn't go in evenly, huh? Okay, so I end up having a mixed number. Okay, how do I get it? 115. I could simplify before I start and say 5 goes into this 3 times, 5 goes into that 20 times, and use 3 into 20, but I'm still not getting a number that's even. 6 times 3 is 18. My remainder goes on top, divisor on the bottom. So this 15 goes into 100 6 2/3 times. So I have a 6 2/3 here. I need to have a 6 2/3 here. And that's confusing for kids to have fractions of fractions, right? But remember, anything over the same thing as 1, even 6 2/3 over 6 2/3. You go figure that out. And again, sorry, I'm not a fan of that problem, but who knows? Maybe they're smarter than me. That's always a good bet. And it's good for you to challenge your brain like that. Okay. So try it. You can do it. Maria was putting together party favors for her niece's birthday party. She put 3 chocolate candies and 4 hard candies in each bag. If Maria had 10 bags, how many candies does she use in all? To represent the total, you can write an expression of 10 times 3 plus 4. What expression would you write to represent the total number of candies used if Maria had to make 12 bags of party favors? All right. So they kind of tell you a lot of this, right? 10 bags, how many would you use? And they kind of told you this is going to be 10, right? 3 of the chocolates plus 4 of the hard candies. Figure that out. Okay. And if she was going to make 12, bags, then, so what expression would she use to 12? So I'm going to let you figure that one out. I think you could do that. All right, last problem. Generic rectangle. 467 times 392. That's big and messy, but it's not too hard. It's just a bunch of steps, right? All right. 467, 400. What goes here? 60. What goes here? 7. 392. Multiply get each of these, add those 9 numbers, and then double check it using the standard algorithm. Okay. All right. Good luck, everybody. I know that's a long one. Okay. Hopefully you have a great day, and don't forget those con minutes. It's Thursday.